So today we're going to look at Chapter 2, Section 2, Part A, and then when we come back we'll do Part B. And we're going to look at quadratic functions, and we've looked at quadratic functions before. We've looked at quadratic functions many of times through our mathematical career. One way to write quadratic functions, we could say f of x equals ax squared plus bx plus c, and we could get some valuable information off of that. And if we just kind of do, let's just do like a quick overview of like when it comes to quadratics and what those all kind of look like and some of the terminology we have. So I'm going to draw a graph. I'm going to attempt to draw a graph. So we got our XY axes, and I'm just going to, randomly just draw this little guy, this little quadratic, right? And so when we come to our graphs of quadratic functions, we say that they make a parabola. That's the shape that it makes, right? And then there's some important little points or parts when it comes to our little parabola. One of those, I'm just going to perfectly drawn, right? This is called the turning point, or we refer to it as our vertex. And at our vertex, that's a turning point. So what do I mean by a turning point? So if I'm following along this graph and I'm reading it like a book from left to right, my graph is going down, or I'm decreasing in my y values. And then when I get to this point called the vertex, all of a sudden my y values are no longer going or decreasing, they are now increasing. So it's called a turning point, because your y values, instead of getting less, are getting greater, or the opposite way. If our parabola was shaped this way, right, that turning point right here, my graph is, my my y values are getting larger until I get to that vertex, and then they start to decreasing again. So we refer to it as the vertex or the turning point. And the vertex is a point that's on our graph, and then we just denote it a lot of times with an HK. So that way if we see something written as HK is 0, -3, we know that that's referring to the vertex. At those turning points are either going to give us our largest value or our smallest value for our y. So for example, on this one, I am decreasing until I get to this point, and then I start increasing again. So if I'm thinking, does this have a maximum or a minimum? Well, these arrows are telling me that the graph goes on forever, so I'm going to continue to go up. So my y values are going to continue to increase. But there is a minimum value, because at that turning point, I'm going down until I get to that turning point, and then I start coming up. So that is a minimum for our graph on this one. So this would be an example of having a minimum. And when we talk about our maximums and minimums, we're talking about our y value, our upward, how high or how low. So on this one, we're just going to, I'm going to go 1, 2, 3, just cheesy, putting it on there and saying that it has a minimum value, and our minimum value is when y equaled 3, just on this example. When it comes to our vertex will give us this thing called our line of symmetry, and symmetry means it's going to be the same thing on one side as the other. So where my vertex is right here, my y-axis actually becomes that line of symmetry as well. So my line of symmetry, whatever I have on the left side, on that line of symmetry, it matches perfectly, right? It's that mirror image. That's what symmetry is, that mirror image. So I always can find my line of symmetry. And my vertex is always going to help out with that line of symmetry. My vertex, that vertex, on our example we said it was 0, -3, right? And when I want to come up with my line is going this way. So I have a vertical line, and my vertical line is going through when x equals 0, right? I have no other x values on that line. The only x value I have on this line is when x equals 0. Y goes from negative infinity to positive infinity. So my line of symmetry is going to be when x equals 0, right? So that's another very important clue or tool when it comes to our quadratics. All right, I think that was a little review on a lot of things. I think we've reached all of our, I think we covered it all. If not, we'll catch up back to it when we come across it. All right, so I know in Algebra 2, and I don't know about in Algebra 1, but I know in Algebra 2, we started talking about this form, vertex form. It's also referred to as the graphing form. And it's very useful to helping us make graphs, hence the name, right? So we say that the graphing form, f of x equals a x minus h squared plus k. So if we kind of want to go through and do some little labeling, hk, we know that is our vertex. Okay. A out front is going to help us with directionality. If it's positive, it's going to open up, right? If A is negative, what's it do? I didn't hear you, sorry, repeat that. Right, it opens down. Right? If A is greater than 1, we're just going to say greater than a positive 1, that makes the graph stretch. We're getting there faster, so it makes it to where you have a skinnier like parabola because you're getting there twice as fast if it was a whole number greater than 1. If it's a number between 0 and 1, so we're just keeping it positive. Let's say a half, you're traveling at half the speed, so it's going to take you longer to get there, so then your parabola is going to be what they call compressed. It's like you're pushing it down, you're squashing it out or spreading it out, right? So let's just jump into a little example. And let's say we had f of x equaled negative 2 x minus 3 squared plus 8. So the first thing we want to find is our vertex. So our vertex is that hk in our little equation in our function. So our h, so x minus h, x minus 3. So I want to find my h. So my h is going to be 3, and my k is going to be 8. So if I wanted to start making a graph, all right, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So my vertex would be right about there. Right? When it comes to our direction, we're going to look at our A, and our A is negative, and since it's negative, we know that it's going to end up going down, right? So the next thing we want to actually find is our X-intercept. I'm going to late number these. So number 1 was the vertex. Number 2 is going to be our X-intercept. So definition of X-intercept is where it crosses the x-axis. So as my parabola opening downward, right, it's going to cross the x-axis someplace. And I bet you it's going to cross it at least, or it's going to cross it twice, right? Somewhere along there. So we want to be able to figure out what our x-intercept is. So you have a couple options on these. When it comes to these, we know that x-intercept crossing the x-axis, our y value is going to equal 0. So we would have 0 equals negative 2 x minus 3 squared plus 8. So we can just go through and do some algebra to figure out what our x-intercept is. So we got to get x by itself, so I'm going to subtract 8 from both sides. So I'm going to get negative 8 equals negative 2x minus 3 squared. I want to get rid of my negative 2 out front. So I'm going to divide by negative 2. So I'm going to get 4 equals x minus 3 squared. So now I need to get rid of my square root. So I'm going to take the square root of both sides. So I'm going to get plus or minus the square root of 4 equals the square root of x minus 3 squared. The square root of 4, so I'm going to get a positive or a negative 2. And when I take the square root of a square, I'm going to get just what is inside, so x minus 3. So now I technically kind of have two equations going on here, right? I either have, well, we can add 3, so I'd have plus or minus 2 plus 3 equals x, right? So I'm either going to have the positive 2 plus 3, which is going to give me when x equals 5, or I'm going to have negative 2 plus 3, which is going to give me 1. I'm going to rewrite that a little bit, right? So we found out that we have it when x equals 5 and when x equaled 1, positive 1, right? So that's my x-intercept. So I can actually put that on my graph. 1, 2, 3, 4, 5. So I'm going to cross when x equals 1, and I'm going to cross when x equals 5. So now my graph is getting more and more accurate, right? I know that I'm going to cross here, and I'm going to kind of go this way. Only thing is like when it comes to my y-axis, where am I going to cross? Where am I going to cross the y-axis? So guess what number 3 is going to be? We're going to find our y-intercept. So definition of y-intercept is where it crosses the y-axis. And when I cross the y-axis, what's my x value always going to be? It's always going to be 0. So I'm just going to plug that into my original, oh, I didn't want to do that, into my original equation, or my original quadratic, right? So I am going to have negative 2 times, I'm putting in 0 for x, 0 minus 3 squared plus 8. So then we're just going to, because that's what we're looking for, our y, so y equals negative 3 squared is 9, 9 times 2 is negative 18, 18 plus 8, y equals negative 10. So where am I crossing the y-axis? If I had drawn this line a little straighter, it might have helped, huh? At negative 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then there's my y-intercept. So now in a continuous flowing motion, right? Sometimes you just gotta use that a little imagination, maybe make your dots a little bigger, make your lines a little thicker. Just close your eyes and draw. Right. All right, close enough. So we have a couple more things we need. We have our vertex, we have our x-intercept, we have our y-intercept. I keep those. So the fourth thing we had talked about was that axes of symmetry. Right. And we're going to get that off of our vertex, because we knew that our vertex was 3a. So our axes of symmetry is that line that goes right down the middle, right? That matches perfectly on left and right. Hey, I'm looking kind of Christmassy, aren't I? So I know that that's a vertical line, so that's when we have a x is going to equal something, and it's just going to be off of our vertex. So we know our axes of symmetry is x equals 3. Number 5, does it have a maximum or a minimum? So on ours, it has a maximum, right? This is going down forever. It's going minimally. It's going to continue to decrease minimally. So as I come up to my turning point, I'm increasing, 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 and then I turn and I start decreasing. So I have a top to it, so I have a maximum. So we have a maximum. And our maximum is when y equals 8, right? I'm running out of room. Oh boy, we're going to kind of go out of order a little bit. Now I'm going to come up here. Number 6 would be our domain and our range. So if I want to talk about domain, domain is my x values. So even though I'm coming down, like I'm going to exaggerate here, right? Like I'm still continuing to go to the left, to the left, to the left, right? Same thing over here. I'm going to keep going farther and farther and farther to the right. So my domain is going to be from negative infinity to infinity. And I'm going to use parentheses because I can't get to infinity. And then when it comes to my range is my y values. So what's the smallest y value I'm using? I'm going to keep going down, so the smallest value is negative infinity, and I can't equal negative infinity, so I got my parentheses around there. And then when it comes to my y values, so I'm going up, I'm going up, I'm going up, I'm going up. Uh-oh, I can't go up any farther. So my range only goes up until where my y is 8, and I can be 8. Right? Alrighty. Sometimes they like to give these to us, and they don't like to give us to it in the vertex or the graphing form. They want to give it to us in the standard form. So standard form, that's what we showed at the very beginning. So that would be when we have ax squared plus bx plus c equals 0, right? Or actually it doesn't even have to equal 0. It can equal, I'll put it up front. We can say our y value f of x equals our standard. So when it comes to this, and it's like, well, it's really hard to figure out what the vertex is just by looking at it. So we can find the vertex. The vertex, we have a little formula to find the vertex. So to find the vertex, it's negative b divided by 2a, and that's going to give you that h value, right, which is the same thing as our x value. And then we're going to take that value and we're going to plug it back into our equation, or back into our function, and it's going to give us our k, or our y value. So it looks a little complicated, but hopefully once we go through one example, you'll be like, oh, I get it now. So let's say they gave us the quadratic function f of x equals negative x squared minus 2x plus 1. A couple things we can say is we do know that it's going to open down because of the negative, right? So let's start with finding our vertex. Well, let's do this. So what's our a going to equal? Our a is going to equal negative 1. Our b is going to equal negative 2. And our c is going to equal 1. We really don't need our c yet, but coming. All right. So to figure out my h value of my vertex, I'm going to put it into my negative b over 2a, right? So negative b, so negative 2, right, it's our b, over 2 times a, which is negative 1. So I'm going to get what? A positive 2 over a negative 2, and that's going to give me negative 1. So when it comes to my vertex, my h value is negative 1. Now I need to figure out my k value, which is the same thing as a y. We're just putting in k because it's the vertex. So if I know what my x is, what am I going to do with my x? I'm going to put it in for x. Yep. So to find out my k, I'm going to have negative, what's my x value? Negative 1 squared minus 2 times negative 1 plus 1. Negative 1 squared is a positive 1, times the negative is going to make it negative 1. Negative 2 times negative 1 is plus 2 plus 1, and that's going to get us to 2. So my vertex is negative 1, 2. So now that I know my vertex, I can go right back and I can do all of this stuff with my equation, right? I have my vertex. So that was number 1. Right? Number 2 was finding the X-intercept. So to figure out the X-intercept, y is going to equal 0. Right? So we would have 0 equals negative x squared minus 2x plus 1. So if you wanted to, you could even use the quadratic formula for this, right? Or you could try and factor it. Right? So x equals negative b plus or minus b squared minus 4 times a times c, which is going to give me a positive 4 all over 2a, negative 2. So now I have 2 plus or minus the square root of 8 over negative 2. Need to break that down. 2 plus or minus, ooh, I'm going to do it below. 2 plus or minus, and I'm going to break that down into the square root of 4 times the square root of 2 all over negative 2. So 2 plus or minus 2 square root of 2 all over negative 2. Okay. So at this point, I can either know that I can reduce all of my 2's, or I'm going to write it as 2 fractions. So I'd write it as like negative 2 over 2 plus or minus 2 times the square root of 2 over 2. Then I can negative 2 over 2, that's going to cancel down or reduce down to negative 1 plus or minus square root of 2. And then if we're graphing this, then you're going to want to put those into your calculator just to see what those approximate values are, because I don't think like in the top of our head, some of us might not be good at figuring out what negative 1 plus or minus the square root of 2 is. And it should be, I don't know, x is approximately negative 1 square root of 2 over 2. I'm going to go with like a 0.4-ish. And x equals probably a negative 2.4-ish. I think it's 0.4, yep. So that's going to tell you where your X-intercept is. You can figure out your Y-intercept, right? Plug in zeros, or this is where that C value comes in. If I'm looking for my Y-intercept, my X values are going to be 0, so that's going to go away. So when it comes to number 3, which was our Y-intercept, that's going to be when our x is 0, so our y-intercept is at 1, right? What else did we have? Axes of symmetry. Axes of symmetry goes off of your x value of your vertex. Maximum or a minimum. Well, if I look at this one, if this is negative, I know that it's going to be upside down. Right? So I got to have a maximum, and that maximum value is going to be at the vertex, so the maximum value is going to be at 2. And then domain and range, your domain, your x values are going to be all real numbers. Your range is going to be from negative infinity until you get to that vertex, which is 2. So from negative infinity all the way to 2. So I'm going to give you guys some time to try working on these ones. I kind of mixed up the problems a little bit. You have some of them that are written in vertex form, seeing if you can find the graphs and figuring out all this information, and then some on the standard form, figuring out all that information. So I'm here all hour.